All right, everybody. So this is going to be a quick review of quiz 1.3. Um, our first question here, we see two amino acids and they get bonded together and water is removed. You should be able to recognize this diagram. You should be able to identify amino acids by their structure, as well as what a dehydration synthesis is whenever two monomers are combined and water is removed. The question here is, which of the following is an accurate description of the process shown in figure 1? The correct answer, the one most often selected, was the formation of a covalent peptide bond in a dehydration synthesis reaction, right? So the bond here is a covalent bond, and it is a dehydration synthesis. Some of you were drawn away from the correct answer by this one. The hydrolysis of amino acids with the breaking of covalent bonds with the release of water. The hydrolysis of amino acids would involve involves breaking. Lysis, that root word means to break. So hydrolysis happens to amino acids, but that would be if the reaction was in reverse. And so when proteins are digested, broken apart, what happens is water is added back, which causes the bond to break. So it's not an ionic bond, and this isn't a carbohydrate. So these two required you to maybe make sure you reviewed the structures of amino acids and the different monomers, right? Glucose and amino acids and fatty acids and things. Okay, question number 2. We had this same diagram, although water isn't shown in this case, but 2 amino acids. Which of the following best describes the formation of the bond in figure 1.1? A covalent bond is formed between a carbon atom and a nitrogen atom, along with the formation of water. Now, in this one, they don't show water to you, but it is a covalent bond between the carbon and the nitrogen. And the result is going to have to be the loss of the hydrogen here and this OH group here, which will become water. Now, some of you selected an ionic bond between the carbon of one amino acid and the nitrogen of another. It's not an ionic bond. It is a covalent bond. It's important to make sure most bonds in living in biology related to life, right? So organic chemistry, they're almost all covalent bonds. Now, water has covalent bonds, and it also has hydrogen bonding between adjacent water molecules, and water can break apart ionic bonds. It's not that ions aren't important, they are, but the bonds that create the major macromolecules of life are almost all covalent bonds. And then a lot of you selected a covalent bond is formed that replaces the hydrogen bond between the OH group and the H atoms. And there is no hydrogen bond here. This is where people often get confused when they start looking at organic chemistry and thinking about hydrogen bonding. Hydrogen bonding doesn't actually have that much to do with hydrogen. It only gets that name because hydrogen is often involved in the bonding, but it's not even always involved. It can be other elements as well. The hydrogen often is kind of it's weak, not very strong at sharing its electrons, so it tends to give away more of its electrons. So hydrogen tends to be more positive, but not always. In this amino acid, there is no there is no hydrogen bonding forces that would occur. There's no positive and negative poles to this. And so hydrogen is giving up its covalent bond with nitrogen. The OH group here is giving up its covalent bond with carbon. So again, it's that distinction between hydrogen and covalent bonding. And you can expect that I will probe that area of your understanding with the assessment on Wednesday. I'm going to be interested to see how many of you can differentiate covalent bonding from hydrogen bonding and the forces that form a covalent bond, that sharing of electrons, from the forces that form hydrogen bonds, which is the unequal sharing, the polarity set up by an electronegative covalent bond that leads to a different type of bond entirely, which is hydrogen bonding between adjacent molecules. You can expect questions that will address that. Okay, then the final question, we have polypeptides are continuously being formed and degraded. One of these processes is shown. In this case, we have a long polypeptide. I always look for the double bonded oxygen here. It's kind of my clue that there's another amino acid. So I have 1, 2, 3, 4, 5, 6 amino acids here. You could also look for the nitrogens. But in either case, we see that water is added and an OH forms on this carbon and a hydrogen attaches to the nitrogen here, and now we are divided into 3 peptide chains. Most people understood that this represented a polypeptide chain that is broken down through hydrolysis, which is the breaking. Some of you selected that this was monomers being linked, but in this case we see they're actually separated. So the long chain is up here and then the chain is being broken down. And I think that's more just paying closer attention. All right. Let me know if you have questions on this. Thank you.